Hi, my name is Greg Kane, and I'm going to be going over the benefits of using Intel Xeon 6 processors with HPE's HPE Morpheus VM Essential software. First, we're going to do a high-level overview of what that product is from HPE. They recently acquired Morpheus, and as part of that acquisition, they have an offering that's called VM Essentials, which provides a terrific virtualization alternative to existing virtual machines, including VMware. It's also great in that it supports both simultaneously, both VMware and the virtual machines, the VM Essentials machines available through Morpheus in a single pane of glass. Customers can slowly deploy the virtual VM Essentials machines, VM Essentials virtualization software, while still maintaining their VMware virtual machines and manage them all within a single pane of glass. And the software doesn't require a forklift of all of your existing virtual machines from VMware to be replaced immediately. They can slowly be converted from VMware into KVM or even coexist over time within the same software package. This is an overview of what the UI looks like. It's very clean and streamlined. And again, you can manage both VMware software within this interface as well as the VM Essentials software. The VM Essentials software is supported on multiple generations of Intel processors and DL380 systems, all the way back to Gen 10 Plus systems, and Gen 11 included. And then for the Gen 12 systems, they support the DL320 and DL360, 1U, one socket and two socket systems, as well as the 2U servers, the DL340 and DL380, one socket and two socket servers as well. What we're looking at here is the DL380 Gen 12 system, and that's what we're going to be sharing what our performance numbers are within the VM Essentials software. So we looked at two workloads. One was MS SQL 2022, HammerDB, a database workload, and we looked at the performance of this workload on a bare metal deployment in comparison to one done through VM Essentials. And then the second workload that we looked at was a Gen AI workload looking at Llama 3.1 with 8 billion parameters, where we were determining how many simultaneous or concurrent users we could support on a single node of this DL380 Gen 12 system, while still providing a very usable SLA or rate at which the tokens are generated. And we'll show what that looks like here in a minute. So what we saw in the database, after a couple months of working with HPE, engineers working together, we were able to optimize the software to deliver as much as 95%, actually more than 95% efficiency of what we were able to achieve on the bare metal system. So running the HammerDB database workload on the DL380 without virtualization, when we compared that with running the database within the virtualized environment, we got 96%, more than 95% of the performance of what we're able to achieve on a bare metal system. So very efficient, very great application of workloads, great efficiency even within a virtualized environment. And then for our Llama 3.1 inference workload, what you're looking at here are a bunch of numbers that represent how many input tokens were used and how many output tokens were generated for each of these runs. And the number above shows how many simultaneous users we were able to support on this system, actually with a single socket, not even with both sockets populated, while delivering an SLA of less than 150 milliseconds time per output token. That might sound like a lot of words and numbers that may not make a lot of sense to you. We'll show you a video in just 1 second about what that looks like and what the implication is. So looking at this video, you can see the words being generated here. That is your time per output token rate. So this is about the performance that you would expect to see on this system, but imagine that with 192 simultaneous instances delivering this level of performance without any hardware acceleration at all. This is all done just through the Xeon 6 CPU on the DL380A system. So what we've shown today is that you can get, and this is all within the virtualized environment as well. This is not bare metal. So within a virtualized environment, you're able to deliver very good inference performance. So that's what we have to share today. Thank you.